Hi guys, welcome to part 2 of this presentation concerning the project of on the retrograde motion of Mars. The first part basically of this recording dealt with the first part of the project, namely the fact that you have to basically plot the path of Jupiter, of Mars on the night sky using the data that you were given for the different dates on one and where Mars is located using the right ascension and declination. So you take that information and you basically draw the path of that planet, and you will see that at some point it's going to be moving prograde from the beginning. Actually, it's going to be prograde motion. Then it's going to retrograde, move backward, and then it's going to move forward. There is a line in the graph that you guys need to be is drawn for you guys. It's called the ecliptic, and that is the path of the sun, basically, which is, as I said in the previous recording, is a projection of the path of the Earth around the sun. This is basically what we know today based on the heliocentric model. In the geocentric model, it was actually the path of the sun. So actually, the second part of the project deals with these two models and how we're going to interpret the motion of Mars using those two models. So let me share with you the screen. So this is where we are right now in terms of the project. We did the first part, as I was saying. Those dots are part of the ecliptic on this path, basically around it. Okay. Now, the second part, as I was saying, deals with these two models and how we're going to interpret that motion using first the geocentric model. With the geocentric model, basically the Earth is in the center of the solar system, and planets, including the sun, also revolve around the Earth. In a way, to explain the retrograde motion, Mars goes around the circle, small circle, and the center of that circle moves on a big circle around the Earth. So that explains, in a sense, how Mars, at some point, while it's going on the small circle, is going backward. So this is how the model works. Whereas in the heliocentric model, the sun actually is in the center of the solar system. Both the Earth and Mars actually orbit the sun, but they orbit at different rates, meaning that the Earth moves faster around the sun because of the third law of Kepler than Mars does. Look at the distance between 1 and 2 for the Earth. It's greater than the distance between 1 and 2. Mars covers less distance than the Earth does. And it's the same thing true between 2 and 3 and 2 and 3 and so on and so forth. So those numbers of the Earth for the inner circle and different positions for the Mars for the outer circle. And this is also true for the case of the geocentric model. The Earth, of course, in the geocentric model is immobile, it's not moving, whereas Mars is moving, and we have different locations for it based on this model and positions. You're looking when you are standing on the Earth looking at Mars. First of all, in this one in here, we're going to draw a line from the Earth to position 1 as projected on the night sky. So this line needs to extend all the way from the Earth, go through 1, and go all the way to the background stars. This is position 1. Later, you should see the position of Mars change. Again, you're going to draw a line from the Earth to position 2, and then projected on the night sky. So this line needs to extend at least to this straight line in here on the right-hand side. And the same thing true. when Mars changes location to position 3, you're going to draw a line from the Earth to position 3 and project it on the screen, and so on and so forth. You will notice that the projection is going up, up, and then at some point it's going to start coming down, down, and then it's going to move up, up. So when it starts coming down, that is where the retrograde starts. And then when it resumes its motion upward, that is when the prograde motion starts again. Same thing in this case too. The sun is fixed, but the Earth and Mars are moving. For a person sitting on Earth looking at Mars, I'm going to draw from position 1 to position 1, basically. So I'm going to draw a line from 1 to 1 and project it on the screen also, on that line there. When Mars moves to position 2, Earth moves to position 2 also. So I'm going to draw from position 2 to position 2 all the way to the end. From position 3 to position 3 also, all the way to the screen. From position 4 of the Earth to position 4 of the Sun, of Mars, and then extend that line all the way to the projection of the screen. I will notice also that Mars will be moving upward, 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 and then it starts to come down. That is when it starts its retrograde motion, and then it's going to move up, up, up again. That is when it continues its prograde motion. So these two models basically explain the retrograde motion, whether the Earth is the center of the solar system, the geocentric model, or the sun is. Okay, both of them have an explanation. This one has to do with the rate at which both of them are moving around the sun. And that is the third law of Kepler. Obviously, one of them is an illusion, meaning that Mars is not really actually moving backward. Just the projection, the fact that one of them is moving faster than the other, that's all. So this one should be an illusion, whereas this one should be a real motion backward, because Mars is actually going forward and then coming down and moving forward. So again, if you know from the basics of laws of motion that the change in motion requires a force. So for the case of the geocentric model, we really need another force to explain why Mars does this retrograde motion, whereas in the case of the heliocentric model, all we need is the force of gravity and the fact that the sun is one that is influencing both of them and causing one to move slower than the other because of the third law, namely that p squared equal to a cubed. So this is basically the second part of the project. So let me show you. So the third one starts in here. That's going to be the next recording, basically, on how we do some calculations. So the second part ends in here. So don't forget, the graphs are heavily graded. Okay, so please take care of them. So let me stop sharing. And let me share with you the report and how it looks like. So this is the report. Okay, so this is where the second part starts from. This is basically we're going to be using the heliocentric model and the geocentric model to interpret the motion of Mars, basically retrograde motion of Mars. So let me, it took me back to the first page. So here is basically the second part, as I was saying, going to be the objective in here. And of course, I need to answer those questions. By the way, you can read on this stuff from Unit 11, especially from 11.1 from the book, in this section and onward. You will get more details about this, the dynamics of the planets or the motions of the planets and how they are perceived on Earth, okay? So this is on page 85 from the 6th edition, okay? So now comes the drawing. Let me see if I can get the tools in here, the commenting tools in here. Where is the, move this out of the way. And okay, I need to draw things. So trying to see if I can find something to draw with. Obviously, if I can do it, electronically, I should print this one and do it manually because I really am looking for something that looks neat, okay? I'm gonna draw a line. So let me first of all zoom in on this thing in here. And So as I was saying, I'm on Earth looking at Mars. This is how Mars looks like in the night sky. It's in position 1. So I'm going to change the commenting in here and probably add the text. Yeah, in here. Can I do that? And I'm going to put position 1 in here. So this is when Mars was in position 1. I'm going to do the same thing, but for position 2 now. So I have to be careful in here because the cursor changes from. So let me see if I can. Oh man. So okay. So we got it position 2 now. For some reason, it's not drawing for me position 2. Okay. Okay, so this is good enough. What happened to the text I added? Did I delete it by mistake? So this should be 2. And this should be 1. Okay. And let me add, just for the sake of argument in here, another position 3. As you can clearly see, we are moving forward in here. And so on and so forth. The next one is going to be position 4. And the next one is going to be position 5. You can clearly see that position 4 and position 5 are almost superimposed to one another. And actually position 5 is going to be slightly below position 4. And then 6 is definitely going to be below them. And 7 is going to be below all of them. And 8 is going to be below them. And 9 is still below, but it's moving upward, okay? From 7 to 8, I'm starting the retrograde motion. So this is basically what I'm looking for in here in terms of this one. Obviously, you can do it electronically. Just do it on the print it, and basically, oh, it's not taking me. Okay, so now let me do the second one in here too, just to show you how this works. So from 1 to 1 now. So this is the position 1. This is how it looks like against the background stars, I'm sorry. And this is position 2. So again, I'm on Earth looking at Mars. Okay. Earth moves, Mars moves. Obviously, Earth moves more because of the fact that it's closer to the sun. So this should be position 2. So let me draw 3, position 3. So again, from 3, I'm going to start at 3. I'm going to pass by 3 and see the projection of the planet from position 4. I'm going to do the same thing. Don't forget to label all of this so that you know exactly what you're looking at. Position 5, you can clearly see it's below position 4. Again, it's giving me a retrograde. So the planet was in position 1, move to position 2, move to position 3, move to position 4, and now it moved back to position 5, even below 3. Okay, so this is the retrograde. This is how it looks like against the background stars. And again, I can just do, for the sake of argument, position 6 and here. So it has moved even more, closer to 2. Position 7 is going to resume the retrograde. So remember, position 6 is close from 2. Position 7 is going to move forward, and so on and so forth. So this is what I'm looking for. This is what I'm looking for in terms of the project, in terms of the drawings. Obviously, if you can do it, as I said, electronically, I need to do it, print it, and show that both models actually explain the retrograde motion of Mars. However, there is problems with the first one, the geocentric model, that you need to address. And you need to make the comments in here, answer the arguments in here. Ancient philosophers would argue against the heliocentric model, stating that they did not feel the Earth moving as it revolved around the sun. Actually, you can see the answer in there. It has to do with the inertia, okay? and what is wrong with this argument. And then at the end, you're going to compare the two in here and say, which one do you think is more? I'm going to meet you guys for the, which one is actually better. I'm going to, namely the flaws of the one that we know is flawed, namely the geocentric model. And also, I will meet you guys for the third part, which has to do with making actually predictions. Okay. Thank you. Let me stop the recording.